So here's another ideal gas law problem. Again, let's start by writing down all the information we know. That's sort of the prep work. So it's saying at what temperature? So right away, we know that it's looking for a temperature, so that is I'm gonna put that as my unknown. Will 5 grams of Cl2. So if we remember the ideal gas law says PV equals nRT. And nowhere in the ideal gas law does it say anything about mass. So I'm going to write this down anyway as M, 5 grams, because that's the mass. But the key is I can't actually use this M as it is, because it's nowhere in my ideal gas law. So we'll come back to that in a moment. Keep going. I have here my pressure is 900 millimeters of mercury. And I know my volume is 0.75 liters. And as always, R, you're going to start to remember this number over time. It's 0.0821 liters times atmospheres over moles times Kelvin. So let's identify what we know and what we don't know. We know pressure. We know volume. We, at the moment, do not know moles. We know R, and we're looking for temperature. So the key to this problem is figuring out how many moles I have. So I have the mass, and I also have that it's Cl2. So this is just a matter of saying, okay, I have 5 grams of Cl2, so let's convert that into moles. So 1 mole of Cl2 has a mass of 70.9 grams. So I can do this out, and I can figure out how many moles I have. So 5 divided by 70.9, this is going to give me 0.0705 moles. That is N. And I could round this, but I usually like to round at the end. So I now have N, and now I can do this problem. I'm looking for the temperature. But once again, before we even start, we check our units. I can't stress that enough. So look at everything and make sure they match up. So pressure's in mmHg, millimeters of mercury. That will not cancel with atmospheres. So I cannot use this pressure as it currently stands. So I need to know the conversion rate between millimeters of mercury and atmospheres. This is also something you'll probably come to know very well. 1 atmosphere is equivalent to 760 millimeters of mercury. So if I have 900, that means 760 millimeters of mercury is equivalent to 1 atmosphere. So if I do 900 divided by 760, that is 1.184 atmospheres. Okay? So now I see that matches up, volume matches up, they're both in liters, and moles matches up. So I can actually do this problem solving for temperature. So I'm going to divide both sides by N times R. These cancel, and I get temperature equals PV over N times R. So let's start plugging these in. The pressure was 1.184 atmospheres times the volume, which was 0.750 liters, divided by moles, 0.0705 moles, times 0.0821 liters, atmospheres over moles times Kelvin. And I put the units in here just to show you how this is going to play out. Atmospheres will cancel, liters will cancel, moles will cancel. What's going to be left is Kelvin. So my final answer is going to be in Kelvin. That's important because if it was asking for the final answer in Celsius, you would have to get your answer in Kelvin first and then convert it. You can't get Celsius directly out of this equation. So now I'm going to multiply 1.184 times 0.75 divided by 0.0705 and 0.0821, and I get 153. I'm going to round this off, Kelvin. So that should be my final answer. Fill it in for temperature. And again, if I want to check, I can multiply P times V and nRT and see if these match up. So P times V, 1.184 times 0.75, so 1.184 times 0.75 gives me 0.888. That's kind of funny. And then N times R times T. So N times R times T in Kelvin, so 153 times 0.0705 times 0.0821. I get 0.886. I mean, that's really close. It's just a round off error. So we've done it correctly. So the final answer is 153 Kelvin. And again, if I was asked in Celsius, I would then subtract 273 to get the final answer in Celsius. But I wasn't in this case, it didn't specify, so I can leave it as 153 Kelvin. And that's it. So until next time, I am Derek Genova. Have a delightful day. Delightful day.